Hello everyone. All of us will present the final project. My name is Firdaus.
My name is Alif.
My name is Muhammad Fauzi Abdul Halim.
And our topic is fire tube boiler and computer cooling systems. Okay. Introduction. Final project is the last phase from Introduction to CAE course. An innovative product design have to made by students for enhance their own knowledge from this course and also training their communication and presentation skill. We have two projects. The one is present the fire tube boiler, that's the implementation of heat transfer in fluids, and the other one is computer cooling system. Try to cooling the CPU by the air with controlling the ventilation and fan system with convecting implementation. And this is our agenda. One is introduction, and two is simulation, and simulation 1, result 1, simulation 2, and the last is result 2. Okay. Next is simulation 1 is present with Alif. Thank you.
Okay, in here I want to discuss about my simulation 1. This is the fire tube boiler. Here my project is the effect of the length of the fire tube boiler to water temperature. Okay, a boiler is a closed vessel in which fluid, generally water, is heated. First boiler heating application. This is a various application. First is water heating, second is central heating, third is boiler based power generation, fourth is for cooking, and fifth or the last one is for sanitation. But here we just focus on the first is the water heating. Okay, this is the 3D design of the fire tube boiler that we will discuss about the simulation today. This is the front view. This is the front view of the fire tube boiler. This is the side view, back view, and also the isometric of the fire tube boiler. Okay, preparation and simulation. There are two sections of this simulation of this project. First section is preparation, and the last section is simulation. In the preparation, there are two steps. First step is simulation parameter settings, and the second step is determine the goals. And the simulation step, in the simulation section, there are just one step is a simulation result. Okay, first we will talk about simulation parameter settings. Okay. In the simulation parameter setting, there are some defining parameter. First, this is the display of wizard. If you want to make simulation, we will choose a wizard tool, and this is the first display of the wizard. And here I use a default name for the project name, and click next. This is my unit system that I use for the simulation. I didn't change many parameters, but I just changed some like pressure and stress. I choose megapascal, and then the temperature I use a degree of Celsius. And here we choosing the material that we use for the fluid. In this simulation, I use two material for the fluids. First is for gases, I use the air, and the second one is I use water for the liquids, the liquid that will be heated. And then this is the analysis type of the simulation. In here I use internal flow. This is the analysis type. I use internal because this is internal flow simulation. And here I choose heat conduction in solids and time dependent. For the time dependent, I use total analysis time for 90 seconds, and the output time step is 4 seconds. So I want to know about the effect of the length of the boiler in 90 seconds. It will increasing or decreasing the output of the output temperature of the water. Okay, and I choose next, and here I choose the steel melt for the solid material, and then this is the wall condition parameter. I use a heat transfer coefficient, with the heat transfer coefficient is just 2, and then the temperature of external fluid is around normal temperature is 25 degrees Celsius. And this is the initial condition of the simulation. I didn't change many parameter, but in here I just changed the temperature is to turn to 25 degrees Celsius. And here I click finish. Then I will take a simulation. And here this is the determined goals. In this simulation or in this project I choose 2 goals. Actually it's surface goals. First one is air output or air outlet. I want to know about the temperature in air outlet, and the second one is in the water outlet or water output. I want to know about the temperature of the water in the water outlet. And here this is the result of the simulation. There I have 5 design points. First, the length of the fire tube boiler is just 600, and the design point 2 is 650, and design point 3 is 700, and for the design point 4 is 750, and the last one, design point 5, is around 800. As you can see in the table result or in the infographic result, the temperature of the water out and the air out always decreasing by increasing of the length in the fire tube boiler. So if the length of the fire tube boiler are increasing, the temperature of the water out and the air out will be decreasing, as you can see in this figure. Okay, this is the simulation of the air temperature. This is the video of the airflow, air temperature section, and then this is the infographic of the temperature average of the air out. Okay, this is the water temperature section. This is the water flow simulation, and this is the infographic of the average temperature for water out. Okay, thank you.
Okay, I will continue for simulation 2. Okay, the second simulation is about water cooling in the computer cooling system, which is related to this project, is based on velocity of the liquid. So I use a velocity of the fluid as a variable. So water in the simulation has main function to decrease CPU temperature. Usually we use other liquid in the real life, but in the simulation I use water, and this velocity in the simulation has some effect to the water cooling system cycle. Okay, I want to show this 3D design. This is the assembly of my 3D model. This is assembly from some parts. There's some heatsink, there is some tank, and the CPU. This is all separated, but I reassemble it. And also I make a casing. I use a box as a case, so there is some circulation in the airflow. The first thing that we have to do before we simulate this 3D modeling is to prepare with some preparation. The first thing we have to name it. I name it simulation 2. Next, and I define all dimension and also the unit. And second things, I use some fluids. I choose air as a gases and for cooling system, and also I use a second fluids, a water as a liquid, and I choose a flow type as laminar and turbulent because there is some turbulent in the casing. So next, I use analysis internal as an analysis type, and also I change the gravity to y to y direction, and here there is environment temperature. I adjust it to Taiwan room temperature. It's like Taiwan temperature like 20. Next, in default solid, I use aluminum 6061. Next, in this part, I change the default outer wall thermal condition to heat transfer coefficient with 40 watt per meter cubic Kelvin. And next, here we finalize the per setting. Okay, this is the result that I got with airflow. So this is a fan. I using a GMC fan. The fan is have a diameter of with diameter 12-inch. Yeah, like if I didn't mistaken. And this is the result of the water flow. There is a blue water. The blue water said that it's around 20 to 25 degrees Celsius, and the green and the red is like maximum temperature. And next, this is the result. I want to explain a little bit. I will make some analysis here. So I make a velocity as a variable for this simulation. The design point 1 is 0.001 meter per second, and the second is double, and the design point 3 is triple, and design 4 is 4 times, and design point 5 is 5 times then the design point 1. So in my analysis, in my opinion, this is not really have a really big impact, but in my opinion the optimal design is in design point 3. So the temperature is not really high, but as well the temperature after cooled by heatsink is it's good enough. The design point 3, I think the curve is like it's very good, like yeah, it's the lowest one, well, in the design point 3. But from what I understand, in my understanding, in this graphic, what I see, in my opinion, when the water has a slow velocity, they like absorb more more color, more temperature. But in the design point 3, even though the velocity is faster than point 2, the temperature is lower, especially when it's heated by CPU. I think it's optimal speed for this simulation 79 meter per second. I'm sorry, I think 79 degrees Celsius. So I choose design point 3, 0.003 meter per second. Yeah, so thank you for your attention. We know next year will be even better than the last. We look forward to better and better. Thank you so much.